So hi there, I'm going to walk you through how you create your scale model. The sheet that you should have been given looks like this is creating a scale model. The first thing we got to do is find out what the actual diameters of your two objects are. And so remember, a scale model is, remember, we can't draw an entire size of a planet. We have to shrink it down, but make sure at the same time that the distances are consistent with what the actual size of the object would be. So that's why we call it a scaled model, just like a scaled map. To find the diameters of the actual planets, and we got to do that in kilometers, I recommend using that NASA solar system site again. So just search NASA solar system. Click in here, and then you'll locate your objects. So for fun, I'm just going to use the moons, the one that popped up right here. I'm going to use Enceladus, moon of Saturn. Then I'm going to do another moon. Let's say Jupiter. I'm going to do Europa. Now, if you happen to be doing those objects, great. But the best, easiest way to find them is if you click, let's say let's do Europa first. So Europa is the moon of Jupiter. I'm going to click on Jupiter. Oh, wait, oops, wrong one. I got to go to moons. Moons of Jupiter right here. Then I scroll down, I find it, there's Europa. Now there are a number of tabs that provide a wealth of information, but the easiest way to find the diameter, and I don't want you just Google searching it, right? This site has got everything. You click in depth. And for most of the major objects in our solar system, there'll be an in-depth page. What's that on there? Ooh, let's go size and distance. And sometimes it'll have like a table on the right that says quick facts, but sometimes you just got to do a little digging within the site itself for that object and you'll be able to find it. Okay, so the equatorial diameter of Europa is 3,100 kilometers. So what I'm going to do is I'm going to record that right here. So my first object, I'm going to do writing in Europa. It's 3,100 kilometers. I'm going to write that in. There's one. And so now I'm going to go to, keep zooming in on that by accident. Europa is a cool place because it potentially has liquid ocean water underneath its icy surface. So let's go to moons. Now I'm going to do Enceladus, moon of Saturn. Critical science targets, Enceladus. Okay. And depending on the object, it'll have this quick fact thing pop up right away. When you go to the in-depth and the diameter here, as you can see, it's much smaller than Europa. So I'm going to write in 504 kilometers. Enceladus, 504 kilometers. Okay, and that's really all you're going to need the NASA site for. Now, the next step on the back side of this sheet, that's where I want you to draw your scaled photos, or excuse me, your scaled drawings of those objects. And so the larger of the two objects, in this case, Europa, that's going to be represented by my biggest circle clearly. Enceladus is going to be the smaller one. Now, let's say if you have two objects that are roughly the same size or very close, let's say like Earth and Venus. Earth is a little bit bigger than Venus. So the important thing is when you choose to draw the circle on the backside, it's going to be your call how large you want this initial circle to be, but don't make it too big so that in that event, you can't fit two circles on this page without it going off or the two circles intersecting. Okay, I don't want the circles intersecting. Okay, there should be a circle for one object and then a separate circle for another one. Okay, and so if you need to practice on a separate sheet of paper just to make sure that works, that's fine. So if you're doing a really large object versus a really small one, you can clearly make the bigger object take up more of the page because you know the smaller one is going to be tiny. Let's say if you're doing Jupiter versus Venus or Mercury, for example. Jupiter's a lot bigger. It can take up much more of the page. You could take up over half the page. So I'm going to draw Enceladus. And I'm just going to play around with this a little bit. And what I'm doing right now is I am determining what I want the scale size to be. Because Enceladus is quite a bit smaller than Europa. And what I'm doing before I'm actually drawing right now is I'm just making sure I'm spinning the compass around to make sure that this is going to fit on the page. Okay, I'm going to make that a little bit smaller. And again, this is in pencil. You can always fix it. You can always erase it. So it looks like that's going to fit okay. Good compass form. I'm keeping pressure on the needle. Okay. So that particular circle, this is going to be my Europa. And when I flip this back over, the next step is to find out what our scale factor is. Because you can't now just, I'm just going to shrink this a little bit and draw just a random circle, and that's going to be my Enceladus. No, it doesn't work that way. We have to find out first what the scale factor is before drawing a second circle. So you can't just guess that. I'll tell you how to do it right here. So to find the scale factor, we have one thing already that we need. We have the diameter, but we also have to measure how long or how large that circle I drew was. So I have to take my ruler and I have to measure the scale diameter. And I try to get it as close to the middle as I can. So for me, that's 16.5 centimeters on the dot. So that's not what I'm writing here yet. Okay, so I'm going to put 16.5, and I have to actually divide my largest diameter, which is Europa's 3,100 kilometers, divided by 16.5 centimeters. And so when we do this math, and so what I'm going to do, I'm just going to minimize this. Let's crank out that math. I'll have a kilometer per centimeter amount. So 3,100 divided by 16. Okay, I'm going to round that to the nearest tenth. So for every centimeter, we're going to have 187.9 kilometers. This is actually a typo right here. This should be kilometers. So don't worry about this right here. Okay. So this is my scale factor right here. Okay, 187. So just to repeat that step again, how you find that amount is you divide your largest distance, or largest diameter. Yeah, let's say if you're doing Jupiter versus Earth, you would take Jupiter's diameter and divide that again by the size of the circle you decided to draw. Pretend that this was Jupiter. Okay, so I'm going to divide that by 16.5. You choose the size of your first circle. Okay, as long as you know you're going to have enough space to draw your second. Okay. Now my next step, so my scale factor is, this is it right here, 187.9. Hey, those of you that are doing Europa and Enceladus, well, you could kind of go off of what I'm doing right here. So now we can determine what the size of Enceladus is going to be on the backside of my drawing. But again, I'm going to do another math equation right here. So to find Enceladus, I can kind of write this in the space over here. I'm going to take 504 kilometers, and I divide that by my scale factor of 187.9. Okay, and I'm just going to do the math. 4 divided by 187.9. Okay, so what I get, I'm going to again round that to the 10th. I have 2.7, and this is going to be in centimeters. So my answer is going to give me the size of my second circle for Enceladus, which is 2.7. Okay, so what that means, again, you're not then setting your compass to that number. You have to go by the radius, which is half of that. So if I were to do 2.7 divided by 2. Okay. 2.7 divided by 2. I'm going to go, it's going to be a little past Because if you think about it, you're like, I don't know that math in my head. You could just, oh, that rounds to 3. So what's 3 divided by 2, which is 1.5. Okay, so it's going to be a little bit less than 1.5 right here. Okay, now I can draw my circle. You're not drawing this circle inside of this. You're drawing that separately. So I'm going to draw Enceladus over here. Man, when I think about it, I had no idea that Europa was this much larger than Enceladus. No idea. And that's the goal of this. Why we're doing a scale model is I want you to think, well, I wasn't aware of the size difference. If you were to do this, remember when we did the sun versus Earth, you're like, oh, Earth is like this little tiny dot almost compared to the sun. Objects in our solar system are the same way. Moons can be much larger than one another. Planets can be much larger than one another. But again, the easy thing I did here is Europa was big enough I could take up a good chunk of the page. Be careful if you're doing 2 objects of similar size that you don't run off the page. Now, your next step, since I have Europa and Enceladus, I'd want you to illustrate in color these objects as they look in reality. And then again, you'll be back to using this. This is kind of a really neat picture of what Enceladus looks like. It's thought to have, again, possibly liquid water beneath its surface. Some imagery provides us with ice geysers that we can see coming off, spraying out into space. So use these as images. I want color, detail, and then you'll also label the name of the object. So you'll put Enceladus, put Europa, and then also you'll write in what the actual, you can do this off to the side, what the actual diameter of that is, of that object. And you can also put the scale diameter. Okay, so what that would look like. And I'm just going to do this quickly for the sake of time. So I'm going to label this, and I'm not going to label it on the inside because, I mean, you can if you want after it's illustrated. Europa. Enceladus. And then I can kind of write, I'm going to write scaled diameter, which was 16.5. And then I'm going to write actual diameter. As you can see what I'm doing. And then I'll look back on what was the actual diameter. Europa, 3,100 kilometers. I'll do the same thing for Enceladus. So they're labeled, and you can clearly, your artwork, I know you'll be much more skilled than me in doing this. Labeled, and also put scale diameter and actual diameter for both objects. Now, once it's labeled, colored, illustrated, you'll take a nice photo of this that I can clearly see your beautiful illustrations and all the labels. And then you are going to insert this into a new page that we make in our digital science notebooks. Okay. Notice in the solar system project, we already did the intro. Now we're going to add a page. Now to add a page, you just go to your solar system project, click the 3 dots, add subpage, title it scale model. It should be after your introduction. And then what you can do is, however you want to get your photo into this, that's fine, whether it's through Google Drive or doing it through your phone, email it to yourself, then you'll dump it right in here. Now, if your image, like the planets, are nice and clear, but it's hard to read your labels, please add some text below the picture describing the titles of the objects and the diameters. Okay. Give me a holler if you got questions. If something doesn't make sense, go back through the video. That'll tell you what you need to do. Thanks for listening.